And the Application Architecture Summit continues. This is the session for Influx Data, and let me welcome back Samantha Wang, Product Manager. Samantha, welcome.
Thanks, Vance.
And we're glad to have Samantha with us today. She is responsible for the open source projects at Influx Data, including the InfluxDB open source software, which we'll hear more about this morning. And prior to Influx Data, she worked in product and engineering at Nielsen Company and Verizon. So she knows a lot about the ways of getting data into a real-time environment. And that's what we're going to talk about this morning. Her session is entitled Building Your Data Pipeline, How to Use Time Series Database to Get Insight into Your Devices. And this is really an appropriate topic with us here going into 2020 as the age of instrumentation is upon us. App projects are increasingly leveraging our IoT and other edge devices. And while they're getting smarter, it's getting a little difficult for IT and developer folks to monitor and manage these devices and all the data that goes with them. So Samantha's going to give us a walkthrough of Influx Data Technologies, how time series meets many of these needs, helps you create your real-time data pipelines and manage them equally well. So just before we hand it to Samantha, a quick reminder, you can download her slides. I recommend you do. They are available in that big red button right on the view screen. You can also see that there are some other assets there. They're also available for you without any registration. You did that to join us today. And to connect with Samantha, which we love to have you do, just type in that submit a question box under the view screen. So Samantha, let me turn it back to you and tell us about building your data pipeline and how time series database will help.
Yeah, thanks, Vance. So as Vance mentioned, I'm Samantha Wang, and I'm a product manager here at Influx Data. And today I'm going to talk a little about Influx Data and its products, but also talk to you about how you can use a time series database, specifically in InfluxDB, to get insight into your devices. So what we're going to do today, just to give you a little background on what I'm going to show you and how to use InfluxDB. I started at Influx Data a couple months ago, and I started using, before I even started, I thought about using the bike share program in the San Francisco Bay Area. I think we've all kind of seen these around, maybe around the country, even around the world, these stations that have bikes. And I noticed that the bike station near BART, which is a public transportation here, was out of bikes on a Friday at 6 p.m., a time that I would probably be taking these bikes. And I thought, while I was learning this product, I was like, how can I utilize the data that's provided to me to be notified if bikes are running low? So that was the main objective of this. And so today we're going to just show you how to find station data or any kind of IoT data as well, to configure your Telegraph HTTP plugin, which I'll talk about a little further. Third, talking to you about how to enrich your data using tasks and Flux. Finally, we're going to show you how to set up monitoring and alerting to send you messages to Slack to give you these notifications when things are running low or any other critical information you want to know about. So a little background on Influx Data. Influx Data is the creator of 4 open source projects: Telegraph, InfluxDB, Chronograph, and Capacitor. All of these projects and products were purposely built for time series data. Time series data requires an ingestion of really large volumes of data, and InfluxDB and its other side products help you ingest data real time and transform data and downsample data, and especially help you storage and optimize and compress your data as well. On the right side over here, we have how our data is stored in InfluxDB. It's made of 4 components: the measurements, tags, fields, and timestamps. Your measurement value is essentially that big high-level grouping of data of what you're going to measure. A perfect example that we like to use all the time is weather. So InfluxDB, if you're inputting weather data, your measurement would be weather. Your tags, this is pretty critical to just InfluxDB setup, would be legend of your database or your graph of your time series data. And this is showing the different components of what you're measuring. So that weather example, again, it can be different cities' weathers, different zip codes of weathers, kind of those different lines on your time series graph that you're looking at. Fields as well, you could have a variety of fields. That would be actually that y-axis measurement, talking about what exactly you're measuring. So temperature, humidity, wind speed. In this example that we have listed here, it has voltage, current, and temperature as well. And lastly, most importantly, talking about time series data, it would be the timestamp. And this is really key to Influx. Here it's listed out in Unix format, but every line of your data will have a timestamp correlated to it. These are the main components to your InfluxDB database and is how data will be stored and fed in as well. So I mentioned the 4 components that make up Influx data. In InfluxDB 1.0, it consisted of what we call the tick stack, which is Telegraph, InfluxDB, Chronograph, and Capacitor. And the big thing, it's important to understand just these 4 different components when we talk about 2.0, is that all of these 3 parts of these tick stack were merged into one simple UI. So talking about these 4 components, we had Telegraph. So Telegraph outlined a sample configuration in a bit, but is our agent for collecting and reporting metrics and events. And second is the InfluxDB, which is the purpose-built time series database, kind of that core storage database of our Influx data product. And the C and the K are Chronograph and Capacitor. Chronograph is the visualization tool for DB, and Capacitor is the data processing engine. And the big change from InfluxDB 1.0 to 2.0 is that we took the ICK part of the 1.0 product and merged it into one UI. So this allowed us to manage your data set and view into your data series the visualization aspect, which was previously Chronograph. And so you could plot and visualize your data, as well as do data processing, all in the same UI. So the Telegraph plugin is still separate from the InfluxDB 2.0 product, but we thought that this is just a much easier user interface and can really enhance your capabilities of understanding and querying your time series data. And to mention that we'll be talking about Flux a little more further, but the InfluxDB 2.0 product is really built for Flux capability. So Flux is our querying language, and you have a lot of capability of building Flux queries in the Influx 2.0 UI, as well as just programming with the Flux querying language itself. And to mention that we still have the kind of accessibility that we had in 1.0 and 2.0. For example, you can even see in this architecture here that Grafana is a common visualization tool that people use and connect to InfluxDB. That capability is still possible in Influx 2.0. So all the different features and that flexibility that you had in 1.0 still exists in 2.0. Moving on to talk a little more, how does time series relate to IoT and this whole kind of big buzz and rapid growth around IoT? The main thing we like to understand and think about with time series data in terms of IoT is that IoT data is time series data. If you think about your smart speakers at home, your Alexas, your Google Homes, those are constantly collecting metrics and events based off of time series data. If you think about Nest is one of the most popular things out there. We talked about temperature and weather. Nest is constantly measuring your different weather at the nanosecond, at the millisecond level, and collecting this time series data. So IoT is a perfect use case for time series data. But along with that, it comes with a lot of challenges as well. Challenges with this IoT data is that it's really hard. You have millions, occasionally billions of sensors, and it's hard to process these large amounts of time series data. And as well, it is difficult to visualize this time series data. With all these different sensors, the picture in the slide shows kind of a wind farm. It's really important to monitor and alert on this type of IoT data as well. So we'll talk about how InfluxDB can help you do that. Is a really good use case for monitoring your IoT devices. So now I'm going to go into a little more on how I'm going to be walking through InfluxDB. We're going to be using InfluxDB 2.0, the cloud product, and just a little more on how to set up and see information into your devices. As I mentioned in the beginning, that we're going to be using the Bay Area bike share system, which is called Bay Wheels. It's owned by Lyft. And they have bike share stations all across the Bay Area. If you're familiar with the Bay Area, they have them in San Francisco, across the Bay, in Oakland, and in San Jose as well. And they publish their real-time station information in JSON format. And this is a perfect format for ingesting data into Influx. You can ingest a variety of types of data, but JSON is really common for real-time streaming data, and you can easily do this with our Telegraph plugin. And Lyft and Bay Wheels, they provided station status information, so almost real time. We'll station status information, just how many bikes are available, how many docks are available, and as well as metadata for the stations as well. So the station name, the station ID, the location, and the regions, and just kind of everything that you would think would correlate to the station information. So first, in ingesting your data that we retrieved from Bay Wheels, we're going to use Telegraph, which is the agent for collecting metrics and events. And this is all a plug-in driven server agent. And we have over 200 plus Telegraph plugins, input plugins. And a lot of these are actually built by users like yourselves from the open source community. In this use case, we're going to be using the HTTP plugin. And if you happen to open and look at the JSON files from Lyft, you'll see that the interval that they send the data in is set at 300 seconds. So it's important to notice that almost a lot of settings that we have in this specific HTTP plugin are default settings, but I chose to set my interval at 300 seconds because Lyft and Bay Wheels weren't reporting any more often. So I would ingest it just every 5 minutes, just around the same time that they are updating the station information as well. We used the HTTP plugin for the input plugin and using the InfluxDB Cloud 2.0 output plugin. This kind of caters to that flexibility that you have with our products. Is we have a lot of output plugins as well, where you can output your data to not necessarily InfluxDB. We want you to do it to InfluxDB, but you have other options as well. So this is what would look like if once you ingest the data into InfluxDB and open up the UI, is that you can see here we have our measurement value as Bay Wheels, we have our tags as station ID, and we have our field as the number of bikes available. But the key thing here with the data that was provided from just the station status information is that they only provided all the metrics in correlation to the station ID. Right here, I've highlighted station 100, but I don't necessarily know what station it is. I could go through a bunch of just mapping back and forth to figure out what station that is, but just purely from our data right now, we don't know what that is yet. So in order to do so, we have to input our metadata file. This metadata Telegraph configuration is very similar to what I did for the station status information. One of the main things was just highlighting, adding a little more tag keys. Once again, these are the things that these different groupings that we're measuring. So I have station ID, station name, and region. You can see region ID here as well. I mentioned that we have Oakland, San Francisco, San Jose are covered. Those are the main regions. I think Berkeley is one of the regions as well. And so those you would label as your tags. And since this is metadata, there is a lot more string information than I think integer information. So that's something that you would indicate as well in your Telegraph plugin. This is a look at the metadata file. So really similar look on your Data Explorer, but you can see that, okay, we have station information and it actually pops up that name. So I have that name that I'm looking for, 4th Street and 10th Street, correlating to certain stations IDs. But I don't have the station status metric information anymore. This is purely just metadata information in this metadata file that I imported. So how are we going to get these two data sets combined? We're going to actually use Flux, which is Influx's new querying language, to join the two data sets. Just to talk a little about Flux, Flux was developed specifically for developers to use and analyze their data across time. It was designed for querying, analyzing, and acting on time series data specifically. We've been working on Flux querying language. Still, it's very much an open source project. So if you go out and have a chance to write some Flux queries and you want to see some improvements, feel free to submit some issues in our GitHub page. But a big component that we're doing that I think is a big improvement on our 1.0 is that Flux will also include a query builder, which I'm historically not a developer, and I use the query builder every single day to learn Flux, and it's a really great way to get introduced to Flux and understand kind of the basic components. But yeah, we're going to use Flux in enriching our data and joining these two tables, this challenge that was presented when I imported the Bay Wheels data. So this is specifically what my Flux query looks like. I'll talk through about it a little bit. You can see that we have the metadata file. We're calling it metadata. We're essentially just bringing in that last call of the metadata. We call it the piping function, the pipe in, greater the arrow sign. That's a key component to just the Flux language. So you can see that we're using that last function to bring in that last metadata value. And we're also bringing in the station ID and filtering on the measurement of bay wheels meta. And so for the station information as well, we have that labeled as live data. We're using the measurement bay wheels. In this example, I only used the number of bikes that were available. So you can see the field equals number of bikes available. In the actual data set, we have number of docks available, number of bikes not available or like out being used. But for my specific objective, we're only going to look at the number of bikes available for that field. And we're also taking that last table for our task. And we're going to take it, look 10 minutes back. That's that range -10. As I mentioned, Flux is really powerful in time series data. So being able to easily set kind of a time period you're going to be measuring your data at is really important. And the last function that you can see is the join function. This is very common to other SQL join functions you've seen. We're going to take it from the metadata and live data table and join it on the station ID. And we can easily drop columns we don't want to use just to keep our data clean. We can rename columns, a lot of things you commonly do when you with using different data sets. And here we're going to name our new table bay wheels enriched. As I mentioned, you can easily do this within our UI. So this at the bottom here, you can see that I copied the Flux query into the query builder, and that you would just click the top right and save as, and you would save this as a task. You could run it periodically every minute. I set it to 3 minutes just to have it a little less than 5 minutes, but this would run every 3 minutes. This task would run this Flux query and bring you a new line of data in that bay wheels enriched data set. And you can see this is kind of just a history of the schedule of my Flux tasks running. I can see that they were successful. This last one was started and would be completed in looks like an average of 4 to 5 seconds time to complete the task. So really pretty quick and just a big enhancement in our 2.0 product. So lastly, a big part of my objective was to be notified when I was running low on bikes. And how can I do that with InfluxDB? The big things that we do in terms of monitoring alerting is that we're going to set up checks. We have 2 types of checks in our InfluxDB 2.0 product. They're called threshold and deadman checks. The threshold check would be once you reach a threshold, you get alerted. Deadman check is if you don't get data for a period of time, which would be really critical in a lot of use cases. You can think of IoT use cases. If you aren't getting data from your device for a period of time, you want to be alerted right away and troubleshoot the issue. You're going to set up an endpoint. Right now we have Slack, HTTP, and PagerDuty. I'm going to walk through a Slack use case, which you would just create in the Slack app and the webhook. You would need to retrieve a webhook to feed into your Slack app. And then lastly, you would set up notifications on what specifically you'd want to be notified for. Do you want to be notified essentially just maybe every 5 minutes on any information? Do you want to be notified only when on warning situations or only on critical situations? So this is what it would look like to set up a check. You can see here we have I've labeled this as 19th Street BART Station. I took the number of bikes available from the 19th Street BART Station bay wheel station. This is when I get off BART. This is when I want to make sure that there are bikes there for me to use. So this is the one number of bikes available I'm going to look at. And you would be able to set up different thresholds to set as critical. So here I said 0 to 3 bikes. I was going to set up as critical. 3 to 5 bikes I wanted to be warned about. Over 5 bikes, I thought the status would be okay and I would be fine. But yeah, so you can set up different levels for these types of warnings, and you would do this all in the monitoring and alerting section of Influx. So this is what your overall setup would look like. So checks would fall into this left-hand side area over here where we have our 19th Street BART Station check. I'm not going to necessarily talk through how to set up a Slack endpoint. It's a pretty straightforward step-by-step process where you would set up a Slack app, setting it to a workspace. We have a lot really clear in our documentation, and the Slack's documentation as well. But in my example, I have it sending to a Slack endpoint. And then my notification rules. Over here, I have 2 notification rules set up. I'm going to be alerted when they're low on bikes, and I have it toggled on bike information as well. And you can see over here, these are just screenshots from my phone. When I was alerted, I had this on for just bike information in general. So I saw that at 5:20 that my 19th Street station check was okay. There's a lot of stuff you can change with these messages as well. You can see the number of bikes that are available, but you get that flexibility within our alerting and monitoring to draft the type of message that you want to see. So that's the ideal, I think, on getting to that initial objective I want to know. So every time I was leaving the office, I didn't get an alert, I would know I'd be good on bikes. But I just wanted to show you a setup I have that I occasionally just like to check. We're all kind of data nerds these days. That this is my dashboard, just of my Bay Wheels dashboard. In the top left, I have just the latest status level of certain bike stations I care about. So I can see that ones near my apartment are on 8, that 19th Street BART station's at 13. And it's actually pretty interesting. I think sometimes I just like to look at this to see what the trends throughout the day are with different stations, maybe near tourist areas, near Pier 39 versus Caltrain stations. It's interesting to just look at the time series trends of the Bay Wheels and this type of IoT device. That's all I have for you today. Here are some important links that I think that would be useful for you guys. Obviously, the InfluxDB 2.0 cloud instance, we launched that earlier this year. You can go ahead and sign up for free, play around with it, get some data ingested in there. We have our V2 docs page. We have V1 doc page. We have a really good docs team over here, just being able to answer all the questions that you want. Comprehensive Flux docs page. If you want to go ahead and learn Flux as well, go ahead and click on that link, and also link to my blog, which has kind of easy copy and paste abilities of a lot of the code that I have here, walking through the same setup. If you want to walk through this example as your first setup for your InfluxDB instance. And if you have any questions, feel free to email me. My email is over here, and my Twitter handle as well. Otherwise, that's all I have today. Back to you, Vance.
Samantha, great session and a great way to look at time series in the context of real trends among real users of a bicycle, or in this case, an IoT device that actually moves people around. So a really great session.
Thank you, Vance.
You know, Samantha, a lot of folks want to track the actual operation or use of a device, like in your cycle and scooter example, but there are other folks that use IoT in a more industrial setting where data might actually trigger a downstream event or something else that might not be something that's totally discernible by a layman end user, but it's really important to the operation. Can you talk a little bit about any use cases you're seeing for that type of scenario?
Yeah, so you can have a wind turbine farm measuring different power levels, kind of wind speed, energy levels. That's a big kind of use case that we have. One of our customers, they do office management. If you think about how you have an office building with different tenants on different floors, they're controlling different levels of thermostat and using different power levels, but you still need to make sure that everything stays LEED certified. And that is kind of an IoT example that you'll be able to measure the different floors, the different tenants, and making sure that everything is under control. One tenant isn't using too much over a period of time. Looking at those type of industrial examples. And those are really common. That's a common example that an enterprise is using today with our Influx data products.
Cool. You know, let's talk a little bit about the dashboard. In this case, it looked like you could create a dashboard that a non-techie can understand. And yet at the same time, because it is time series, it's probably also looking at purely data stream type data that developer or an IT ops guy would like. Is that also a common environment? We got a couple of questions here about how people are interested in both types of dashboards for different roles.
Actually, one of the biggest use cases for Influx data is kind of the DevOps environment, the IT environment, and just being able to see what the most important metric is. You can just determine if you want to look at the time series data, real-time data is the most important. You can set that to the last 5 minutes, the last 10 minutes, all on your dashboard. We have a lot of NOC centers using Influx data in this dashboard environment. So you can think of a big center with giant screens, and we want to make sure our dashboards can provide the functionality for that type of monitoring.
Yeah, really excellent. In fact, just a quick follow-up on that. Is your dashboard interactive? In other words, can people click down or drill into something that looks a little fishy?
Yeah, like the example I said, you could set it for 5 minutes. If you saw a spike going on at 10:42, you could drill in and see what the problem is and being able to manipulate there as well. And I think a big thing to mention is that all our products are really open source. I think I mentioned the product manager. So if we have a really open GitHub page, if there's kind of features, we're constantly improving on those features. That's just submitting an issue. And that's a good way to just get involved to feel like you're really contributing back to our products.
Absolutely, absolutely. And another use case that apparently is kind of popular is this idea of archival policies for data. Certainly some people can see it, other people can't. How does Influx Data handle some of those varying issues, and is there automation for that?
Yeah, so the big thing with time series data is we've talked about how you can ingest large volume at a small your level. And so when you want to archive that data, it doesn't necessarily always make sense to keep the nanosecond level data from a year ago, even a week ago. And so a big aspect of our capabilities are downsampling data to aggregate this data and to look at it at a different view without having to disrupt storage and performance issues. So that's a big thing in the archival capabilities of Influx.
You know, this is a great conversation so far, Samantha. Given it is application architecture, there's a couple of questions that go to the issue of how do people implement it, install it, and maybe even get it to work with other applications. One of them says, can the speaker talk a little bit about the install issues, especially open source versus the cloud edition?
So the open source version is all downloaded on your local machine. That's kind of the free OSS version on your computer. It's all just built in with installing things on your terminal. And the cloud version is actually even easier to use. Just going to the link that I provided in my presentation, going there, signing up, and everything is kind of set up there and it's easier to walk through, getting your Telegraph plugins set up, getting your monitoring alerting set up. It's something that we are kind of focusing on in the future of Influx. We have a history of developers, which they can get the OSS product set up really quickly, but for the Cloud 2.0 product, we want that time to awesome to be a lot faster. So that Cloud 2.0 product, no installation to just even get it up and open, plugins and starting to retrieve information is getting easier and faster.
And just a quick follow-up, Samantha, on the architecture. You mentioned quite a number of times the Telegraph agent, and that sounds really powerful. Just to get a sense, do people end up individually installing that at each device or on some edge environment, whether it's in the open source edition or the cloud edition?
Yeah, depending on what your architecture looks like, there's a lot of different use cases. You could have one plugin just reading multiple devices. It all depends on just your architecture setup and what would be optimized the most for your situation. We do suggest that you do have it as close to the edge as possible. Just with time series data, we want your events to be coming in as real time and quickly as possible.
You know, Samantha, this has been a great conversation. I see time is just about up, but before you go, given the open source bent and the cloud bent that Influx Data has, I know there's ways for folks to go hands-on with it and take a trial or maybe a sandbox in some way. Give us our options if you could.
Yeah, so as I mentioned, the Cloud 2.0 link is in the last slide of my presentation. That's just a quick, easy way for you to sign up for our product and get started. And we have the V2 docs that would have some other getting started guides if you want to download the OSS product. We have the OSS 1.x versions and 2.0 versions as well. The 2.0 product, mentioned a couple times, it is probably the fastest product to use. And if you just want to get data in and start looking at how to use our product, you can go through and get just looking at your system data. That's a pretty easy thing that's already pre-built in there.
Excellent, excellent. Samantha Wang, Product Manager at Influx Data. Thanks very much for a great look at the importance of the new generation of data pipeline, especially for IoT and Edge, and how it's so important to get that visibility, not just for the developer, but IT, and even the non-technical guy, so they're all on the same page. A really great session.
Thanks, Vance.
Our pleasure, our pleasure. And as we love to do here at the Application Architecture Summit, just a quick reminder, Samantha and her team have brought together some really great assets, including those links to the free trial and the cloud environment. They are available to you right here in the breakout room, right under the view screen. And as you can tell, lots going on at Influx Data these days. We didn't have room for everything, believe it or not. Here's a slide that'll take you directly to the Influx Data website for some more great info. And just a quick tip, you download Samantha Slides and you'll get live versions of these links. Thanks again, everyone.